Sizes because somebody was crying about it.
Are we getting more time?
I gave you some more.
Are we getting more homework tonight?
No new homework tonight.
I don't know why you're yelling.
Okay, no more homework tonight. But we do need to start 2.1. Okay. The way that I'm going to structure class, and again, this is kind of easing you into a more formal college course. Usually in college courses, you have a test about every 5 to 6 weeks in a math class. Usually they break it up to a semester of 18 weeks or 16 weeks. They break it up into 2 to 3 tests. So you might be doing tests over 3 or 4 chapters or 4 or 5 chapters at a time in those courses. It's kind of how Rhodes is set up if you took it on campus at Rhodes. Okay, I'm going to do it a little bit differently. I'm going to do 2 tests. Okay, I think that's going to do 2 things. It's going to obviously make us kind of ease into that transition of having more information on tests down the road, but at the same time, it's going to save us time in regards to finishing the course. Like if we had a test on every single chapter, we would run out of days and we would not get to all the information. Does that make sense? Yes. Can we? Let me get to this, and then once we get done with this, I can get to you, or between classes, I can help you with it. But we have to be able to condense our chapters into 2 chapter unit tests, just for the sake of time, and again to kind of train ourselves into that bigger and bulkier type test. What you're going to find out with this chapter, though, this chapter of redundancy, a little bit of old information, okay, but we're going to hopefully learn it a lot better than we currently understand it. You've been introduced to this stuff in Algebra 2, used a little bit in Algebra 1, but we need a really, really solid foundation about what a function is, different ways to represent a function, what a function tells us, how we interpret functions, because then everything else that we do beyond this section talks about a function. Okay? There's a couple, when we get to conic sections, some of our conic sections are not functions, but everything else beyond this, we're going to have the question or the statement, are we dealing with a function? Because if we are, it's going to get me down this kind of pathway and approach to dealing with the problem, or is it not a function, so it takes me down a different pathway? That kind of makes sense? Okay? So that's where we're headed. Early on, we'll talk about our kind of most basic functions. We'll talk about linear functions. We'll talk about quadratic functions, which we've already dealt with a little bit. The projectile question is a quadratic function question. But then we'll start working with like cubic functions. We'll talk about quartic and quintic and stuff like that, and then applications of those things. So if I'm using a cubic function, maybe an application of that is I've got X amount of material of cardboard. What's the largest volume that I can make for a cardboard box out of that area? Okay, so and we'll maximize those things. You guys do optimization problems last year?
Nope.
You did questions where a farmer has so many feet of fencing. What's the largest area that he can enclose on fencing? You guys did that with a rectangular like pen or something like that. We'll do that, but then we'll work and broaden that with cubics and quartics and quintics and different relationships. On top of that, there are a lot of theorems in calculus that start off with, for a function, if this occurs, then you can do this, okay? So what we talk about here is kind of the backbone for being able to do a lot of our rules and properties inside calculus, okay? A function, simply stated, is a rule that assigns to each element X in a set A. Remember, a set is just a collection of things, right? Okay? What we're usually going to think about is that our set A is the real number line. It's the x-axis is the way we usually think about it, okay? But it takes every and set A and pairs it with exactly one element, which we call f of x, which we review as the function evaluated at x, or maybe you guys remember y, okay, in Algebra 2, and a set B, okay? So set B is usually your y values, or your vertical axes. So that's the definition, okay? And you've got several different ways that we can model that